Good evening, all. Am I audible as well as visible? So, today is the 10th session, and I hope all of you have watched the video lectures. And we will be covering some questions related to the assignment and the topics discussed in this week's lecture. Yeah, so I'll present my screen. So, I hope all of you have watched the videos so that it will be easy when I'm discussing the questions. Is my screen visible to all? Is my screen visible to all? Can anybody please confirm?
Yes, ma'am, it's visible.
Okay, great. Thanks for confirming. Let us proceed with the first question. So, I would encourage all of you to please solve, and if you have solved, then please put your answers in the chat box, and then we will discuss each question one by one. Please attempt this question. All of you should attempt. This is directly from the theoretical concepts discussed in the lecture, and I think this is the first question of your assignment 10 as well. So that will help in solving the assignment, and if you have already solved, then it's good. So please put your answers in the chat box. You can also unmute and tell if you feel like. So I think these kind of MCQs will be there in the exam related to the concepts, multiple choice. I'm not sure about multiple select, but definitely multiple choice will be there. So all of you should solve. I should see lots of answers in the chat box, not just one or two people. So I want all of you should answer. Please attempt. I'm presenting the question again. So what is the answer? What do you mean by an entity? What is entity here? Anybody? What is entity? What in general do you understand by the term entity? Hmm? Please unmute and tell if any one of you knows.
It's a uniquely identifiable element and which is reusable.
Sorry?
Uniquely identifiable element and which is reused
Yes,
can be
that is
labeled as
correct.
an entity.
Yes, that is correct. And it can can include, so you might have heard of this concept also, named entity recognition, right? So what does that include? What do you mean by uniquely identifiable? Is that to recognize means to identify only, okay? So it can be anything. It can be, what will you uniquely identify? The name of a person, place, organization, these kind of the things will come, okay? So we have this one concept in NLP, that is NER. I think that you will see in this lecture as well as in the next lecture videos. So first be clear with what entity is, okay? Then the correct answer is, as someone had rightly written in the chat box, that is option C. So this is directly from the lecture videos if you have watched. So first of all, you will identify, then you select the candidates, and then you disambiguate according to the what is the reference. So I hope that is clear to all. This is directly a theoretical question, not much to explain here. So is that clear? Shall we move ahead? All of you comfortable in this? So I will also open your assignment so that you will see that we are solving very relevant questions this time. I felt it necessary to cover. So if you see the week 10 assignment, so the first step, option C is directly there. Mention, identify, candidate selection, and then reference disambiguation. So similar question I will solve first of all, and then you should attempt. Okay. So the question goes like this. Question 2, if you can see my screen. So the text span S equals to C, the particular word has been given to you. C, and it occurs in 600 different Wikipedia articles. Okay. So now this is C1, how many times it appears in the article first, article second, third article, or it is having linkages to these articles. And this is the time it is not having linkage to any other article. It is not acting as an anchor. So now, given this information, you have to calculate the key phraseness of C in all Wikipedia, in all in according to above information. So all of you should attempt to solve. All of you should attempt. And what are the options? These are the options. So I will write the options here on the side so that it is easy for you. 232,886, 0.232, 0.886, and 688, 0.688, and 0.8976. So all of you should attempt and let me know. At least write the formula. What is the formula for this? That also is okay if you can write. These are the potential options. And please let me know which satisfies. So please attempt. And then we will also solve the questions that are appearing in your assignment. You only will solve. So yeah, please attempt. All of you should attempt. So you have to calculate the key phraseness here. There are two important terms. One is key phraseness and then another one is commonness. So here you have to calculate key phraseness of the mentioned keyword, that is C. I want to see more and more answers in the chat box. So all of you should attempt. Good. All of you should also try. If you see similar question is there in your assignment 10. Similar question. Only the values have been changed. So am I seeing more answers? Others are attempting or they are not able to solve. Please let me know if you need more time. Just raise your hands who needs more time. Okay, good. So let me also open the lecture note so that it is clear why I am taking a particular formula. So from the beginning, we had the first answer for the first question and mention detection, link generation, and then disambiguation. That is clear. Then we go to the second concept, that is key phraseness. So what is key phraseness? The term W is linked to another Wikipedia article, that is C1, C2, C3 in your question. And then what is the collection frequency? How many times this term W is appearing? So your key phraseness formula is this. Okay. And if you see it in terms of links, yeah, well, I think commonness is a different thing. First, let us discuss this. So also written the, let me write the formula here first. CF of W1 upon CF of W, if we go according to the notation in the PDF, number of times W is linked to other Wikipedia article upon frequency of W, means how many times W appears in Wikipedia articles. ठीक है, तो कैसे करेंगे? देखो, कलेक्शन फ्रीक्वेंसी क्या है W1 की यहाँ पे? Okay, so what is the collection frequency? W is linked to C1, that is the first article C1 223 times, article C2 161 times, article C3 18 times, and article C4 11 times. And 187 times it does not have any, it does not have a link to any other Wikipedia articles. So if you sum up all these values, C1 plus C2 plus C3 plus C4 plus no link, then it comes out as 600. That is the frequency of W. Okay. So similar thing I have written here. So this will become number of times it is linked to other Wikipedia articles. Linked to all other Wikipedia articles. Similar thing upon frequency of W. That is simple. You just need to subtract that part of no links. 18 plus 11 upon upon 600. So the answer comes out as 0.688. That is option C answer. So in the similar way, can you attempt question 4? And I want all of you to answer now because I have given you the formula and only the values are changing. So that explanation was clear or not? Was that explanation clear enough? How we have applied the formula? Was it clear to all of you? Great. Now please attempt this question. Similar question, only the values have been changed, or even the values are same or no? No, the values are different. So please all of you should attempt. Same question, same concept, different values. And this is the question from your assignment itself. So it'll be good if you can solve. So I will solve only after I have received more than 5 answers from 5 people in the chat box. You may use your calculator as of now, not a problem. But if you do by hand, that will be good. Increase your speed for the exam.
They do give computer. We can use computer or calculator, right, on the exam.
Is it allowed? I'm not sure. Is it allowed? You must have been given the instructions.
The previous exams, what I've seen, we do it online on the computer, so we use the computer calculate whatever available.
Okay, then it's good. Then you can use calculator. No issue for me.
No special instruction for NLP, right?
No, nothing. Nothing like that. It's just that even opening the calculator takes time. If you are fast in calculation by hand, that will save you 2 minutes. That is what I feel like. Maybe you can see if you are good at using calculator, then please use. Go ahead. So what about others? Are you also able to solve? Only 4 people have answered. Maybe I'll open the question again. So how should we solve it? Again, let us see what is the okay, slide. What is the formula for key phraseness? Collection frequency of W1 upon collection frequency of W. Number of times W appears in all Wikipedia articles, and in the numerator you will have number of times W or is linked to other Wikipedia articles. So that will be how many times it is linked to other. Ignore the no link part. So that will be 189 plus 273 plus 87 plus 53 upon how many times it is occurring in different Wikipedia articles. This is value should appear in your denominator, 764. Or alternatively, you could write 764 minus no link. That is 162 upon 764. This should give you the same answer. And I think the correct answer again should be option C. You can check using the calculator once. Yeah, I should also check. That is 764 minus 162, 602 by 764, 0.7879. So the correct answer is option B. The correct answer is option B. This value is equals to 0.7879, which is approximately 0.788. So I hope this is clear how we have solved. Is it clear or not? Is it clear to all of us? Great. Now, before moving ahead to the question of commonness, let us discuss few more theoretical points about key phraseness. So, where do I have those? Yeah, can you tell me this one? What do you think key phraseness refers to? Does this mean
Option A,
okay? And why do you think that is the answer? I mean, I want to
because
your reasoning
uh,
behind it. Yes, please go ahead.
according to the option, the frequency with which a word appears in a document means that in a given document, how many times of the words has been appeared and how many times it is mentioned to identify. I think so.
Okay. Any other answers, or all of us agree with option A?
It could be C also, how well this mention is encapsulated across the document.
Why? Why is that? Like, may I know your logic behind that?
So, yeah, we are identifying the particular mention, how well it is distributed across how many in a document.
Mm-hmm. Maybe
So,
I didn't get. Could you please repeat, like just once?
so key phraseness, what I understand is how well that mention has been used or distributed across how many concepts in a document.
Mm-hmm. Okay.
So that can relate to a phrase encapsulates a document's core topics, how
Mm-hmm.
well it is encapsulated across the document's core topics.
Okay. Okay. We will see that. Okay. So we have two answers until now, A and C. Anybody wants to go with option B or option D? If yes, then why? If no, then why? Why not option
Madam.
B and option D? We have two potential answers here, A and C. I always tell, I have taken previous sessions also for NLP in the previous runs. I always emphasize, if you know the correct answer, that is super, very good. But then you should also know why the other answers are not correct. That is more important.
Madam,
Yes.
a word can have a multiple senses,
Mm-hmm.
and the sense of any word depends on the context in which it occurs.
Yes.
So I think the option B is the correct one.
But that is talking about the, you are talking about the senses of the word, right? So sense would refer to its meaning or semantic, right?
Yes.
Right? Then is it that sense or semantic? What is the meaning of it? Is that equivalent to its grammatical importance? What does grammar refer to? Syntax? What are
Mm.
the rules? Right?
Yes.
So what you are saying appears to be little contradictory. So see, grammar is like the set of the rules how you will structure your sentence, and structure is syntax, right? In what format you are writing. But then the logic you are giving is related to semantics. What is the different senses of the word? What is the relative context, right? So
Yes.
it seems a little contradictory.
Okay, ma'am.
Yeah. Any other? Anybody else wants to go with B or D? So why are we sure that the answer should not be option
Ma'am,
D?
ma'am,
Yes.
if semantic is given as an option, then it is the correct one, right?
But we are not talking here about syntax and semantics. I just explained what you were saying and what the option is, right?
Okay.
Yeah, understood. I'm saying
Okay.
the option and the logic you are giving does not match. I'm not saying that if semantics were given, it should be the correct option. Okay?
Okay, ma'am.
Okay. We will see in 2 minutes. So anybody else wants to go with B or D? Please interact. It will be good learning for all of us. This is a different question. It is not in your part of your assignment, or you might have seen in the previous assignments. You may have, but 90% not. So anybody wants to go with option D?
No, ma'am.
All of us are sure that the answer should not be option D, right?
Yes.
Okay. Then how many of you think B can be one of the answers?
B also cannot be because we are not considering the grammatics of a word.
Okay.
So it cannot be, B cannot be the option.
Then what about A and C? What do you want to go with?
I prefer in going option A.
Okay. Okay. Let us see now what is the correct answer. Written the solutions this time, so it is later easy for you to later refer to. So the answer is option C. I think someone well pointed out. See, if 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 this is the correct answer, then I think the correct term should be for this term frequency, right? Number of times. What is the term frequency definition? Any one of you remember? In TF-IDF, what is the definition of term frequency? What is the formula? Anybody remembers or not?
How many times a word occurrences in a document?
Hmm.
I think the same definition is here.
And what should be in the denominator?
Mm, absolute of A union B.
No. See, for if option,
Not exactly remember.
yeah, okay, it's fine. Let me discuss. So the correct term for option A should be term frequency, which is number of times term T, or here the word W appears in a document upon what is the number of words in the document, total number of terms in the document. Okay, that will be the frequency, part upon whole, right? The correct term for option A should be term frequency. So the only option that we are left is with C. So sometimes eliminating the wrong option also leads you to the correct answer. Now, if we were just to see why C is the correct answer, so the reasoning goes like this. So it is about identifying the phrases that best represent the essential ideas or the concepts within a document. This is not clearly the answer option A, even if you see the formula. What does the formula state? Collection frequency of W1 upon collection frequency of W. So number of times it is linked to other Wikipedia articles. So how many times this term or this topic is how many times this term is appearing in different documents, or how many times different documents are talking about this topic. So if there were many topics, so you could write a particular document, or and see, a particular document at one time can talk about multiple topics. So you are to find the key phraseness of every word to identify what is the importance of it. Okay, so is it clear? Is it clear to all of us, or is there any doubt? Not clear?
Ma'am, actually the same related question in the assignment 4,
Assignment,
but it talks,
assignment 4.
I mean, question number 4 in say assignment week 10.
uh, in 10 in this.
Yes.
Yes, tell me then, what should it be? I think I have covered this. Can I come back to this question when I am discussing, or let us cover it first? I am covering in a random order today as per your request. It's fine. So I think, yeah, if we discuss that, then it will be more clear. Just a second, let me see where I have what is the question number for it. So we are talking about higher key phraseness. That is directly answer based. uh, I'll also cover 10th. Yeah, so question 11, yeah, can you tell? So, or should I, you want me to discuss? According to you, what is the answer?
Option B.
B.
Yes.
Why?
Because here the mentioned word occurred, key freshness is related to the mention identifier actually. I know this concept. So I'm relating all key freshness with the mention identification.
Okay, what others think about this? Anybody wants to go with option A?
Ma'am, ma'am, question.
Yeah, question is this.
So actually, this in your early question, the key phraseness you have selected the solution, C, right?
Mm-hmm.
But actual definition is key phraseness refers to the linkable candidate, right? That is the actual definition for key phraseness.
Yeah,
So
yeah.
yeah, so this question and the earlier questions really contradicts.
No, it doesn't. Let me help you understand the analogy. Just a second. I also think the answer for question 4 should be A. How many of you agree with me? I'm not sure, the answer key is not yet out. How many of you agree with option A? I can see one.
Uh, yeah, I agree, but also the previous question should be
Yeah,
no option.
hold on, hold on. 2 minutes. Just give me 2 minutes, okay? Give me 2 minutes. I'll come back to it. How many of you agree with option A? Please raise your hands. Nobody agrees except for the one who has written. No one else agree? Then what do you think is the correct answer?
Option B, because the first step for identity linking is to first to detect the uh, mention
Mm-hmm.
detection, right? The first step is mention detection.
Mm-hmm.
So I feel so that will be the highest priority because since that is the first step.
But that is the first step. But then who said that key phraseness refers to the first step? Why don't we just think it like this? That is my analogy. Please let me know in the next lecture if the answer key says a different thing. I would love to discuss it. But according to me, if I write the formula of key phraseness, how I solved it, I will tell. So that is number of times W is linked to other articles upon upon frequency of W or total number of times W appears across all Wikipedia articles. Okay? This is the formula. Now, what is the question asking? If this value is high, then there is only two ways in which can be high. What is the first way in which it can be high? This fraction. If the numerator is big, if the numerator is big and denominator is small, simple maths concept. That is the only way in which it can be high. This probability value. Yes or no? Maximum frequency.
Yes.
Is it correct or not?
Yes.
Right? And if we are talk about probability, then this value should be closest to 1. How it can be closest to 1? If this numerator is very high, right? Or the denominator is very small, right?
Mm-mm.
Then he's excuse me, he is asking about higher value of key phraseness. That directly refers to how many times it acts as a linkable candidates. Because we saw when we are solving the numerical C1, C2, C3, C4, है ना? How many times it is linked to article 1, article 2, W, span W, world, C, right? That is the example we took. So that is why I think the answer should be option A. Because I'm solving by the formula. Number of times W is linked to other candidates. Linked means it acts as a linkable candidate.
So, if the number of that is, if the numerator and if the denominator is more or less near to each other, then my key phrases will be having a small value, right?
Who said so? If this value is very close, right? So say total, say like this. Just a second. Let me choose a pen. Say this value comes out as 690 and the denominator is 750. So this value will be closer to 1 or it will be closer to 0.00 something. You are saying it should be closer to something 0.00 something. It should be small. Rather,
Okay.
if this value was like this 110 over 750, then which is smaller? You tell me.
Mm,
Understood how I have analyzed? Maybe you
yeah,
can
yeah.
also tell me, like, when the answer key is out, we can discuss. I think we have 2 more sessions to go. Or you can always feel free to write me back, right?
Okay,
I
okay.
think the answer is option A. This is my analogy of it. Now, coming to someone was saying it's contradictory. Question 22 solution and this. So I think it is not. Why? Let us see. So it is how well a phrase encapsulates the document's core topics. So if it is linking to other documents, number of links, number of times W is linked to other documents or other articles upon total number of times W appears in all articles. So now let me write it clearly first. Number of times W linked to other articles. So why I am saying key phraseness is about this. It is about identifying the phrases. Given any phrase W, if my key phraseness is high, that means, let's say, my keyword. Key phraseness can be like 2 words. Lovely day, pleasant weather. So these are the so pleasant is one keyword, weather is another keyword, and if I combine these two, this becomes a phrase, right? That is clear to all of us. And if this phrase is linked to other articles, how many times it is linked, and upon how many times it is appearing. If this value is high, that means it is capturing the core idea of the document. This lovely day, this value, the probability of lovely day appearing in this document is high, as well as for the pleasant weather. That means that this document is capturing the important ideas. Yes or no? And not the term frequency. Because if it were the term frequency, then it should be number of times W appears in article A, right? Number of times the word world appears in article A upon total number of times the word world appears across all articles. Then there should not be any concept of it being linked to anything. Okay? Is it clear or not? Always try to refer to the mathematical formula in case you have any doubt. That is my analogy of it. So I hope it is clearer. Is it or is it not? Okay. Thank you. Let us proceed. Let me see if there is one or I think question 10 we have already covered, right? Let me see if there is another question related to key phraseness. Then we'll come to the concept of commonness, because these are the main areas from which numericals can be asked. Okay. Yeah. Question 10. Direct formula. Anybody? I think all of you can answer. I have discussed this now numerous times. What is the answer? formula. I'll write the formula for you. Okay, I think you should attempt. Take 2 minutes. Let us see how many of you solved. B. Okay, that is correct. Why B is correct? Anchor means it acts as a link. That is the only thing here. So answer is B. I think that is pretty clear from the formula. What is the formula? Again and again, same formula comes. Number of times collection frequency of W1 upon collection frequency of W. I'll show you it to you in the PDF. It is written very clearly, the term anchor. Where I will tell. So I hope all of you are able to see. See, term W as a link to another Wikipedia article. Number of Wikipedia articles that use it as an anchor. They are linking to it. Number of articles that mention it at all. Clear? Is it clear why the answer is option B?
Ma'am, that is checking the top. It is checking with the topic, right? Which topic is linking to the document or word? It is checking with the word.
Yes. Clearly the definition from the slide itself. Okay? So these kind of straightforward questions can also be asked for free marks according to me. So yeah. So we have discussed this. Now let us come to this commonness concept. This is also there in your assignment as well. Similar question. I think even the definition is same. If you see, it can be a paragraph kind of a question. So yeah. So S is nothing but world here. So we will solve it using first this one, and then we will move to that assignment question. So see, text span S equals to sorry, this one we will solve first. So span is C, it appears in 600 different Wikipedia articles. These are the values that are given. Now you have to calculate the commonness of S with C2. Okay? So the commonness of S with C2. So let me write C1, C2, C3, C4 here. S is equals to C. Number of time, frequency of S is 600. C1, C2, C3, 223, 161, 18, 11. 263, 161, 18, 11. No links. How many times? 167, I guess. 187. No links is 187, 18, 11, 161, 223, and this is 187. ठीक है, करो इसको. कैसे करेंगे? Apply the formula. Let me show you the formula. Just plug in the values and get the answer. All of you have noted the question? So you are to calculate the commonness of S with C2. Earlier we calculated the key phraseness of S. Not with someone but across the entire Wikipedia articles that it was occurring in. Now you have to here calculate it with a particular article, the commonness. So the formula goes like this, only if it helps. See, this is the formula for commonness. Fraction of times a particular sense is used as a destination in Wikipedia. Please apply this formula. Maybe I will write this formula here so that you can just plug in the values and get the answer. Formula is LWC upon summation of WLWC. This is total mentions. Okay, what do you get as the answer here? Use calculator. Or maybe, okay. We have two answers, C and B. Okay, let us see the solution. Not solved it. Okay, fine. Yeah, fine. New slide. So the commonness of S with C2, this is, the formula states it should be LWC upon summation LWC. What does that mean? The symbols are not enough to understand. CBB. Okay, let us see. Number of links with target C dash and anchor text W. So number of times W is linked with C upon total number of times W is linked with any C. Because if you see here, what the summation is around? The summation is around C, C dash, right? Or you could say I equals to 1 to N L of W comma Ci. So what does that mean according to our question? He is asking about commonness of S with C2. That is commonness of the word C with the document article C2. That is number of times W is linked with C2 and with any C means C1, C2, C3 and C4. What does that mean? Number of times W is linked with C2. What is that? 161. This is the number of times W is linked with it. This is 161 upon number of times W is linked with any C, any Wikipedia article. That is 223 plus 161, that is linked with C2 plus 18 plus 11. तो चेक करो कितना आ रहा है ये. Let us use calculator. That is 223 plus 161 plus 18 plus 11. It comes out as 413. That is 61 by 413. 0.389. What is that option? B. Clear है? Is it clear to all of us? बताइए. Is it clear to all of us?
Yes, ma'am.
Great. Now solve a similar question. What is that? The question is this. Can you see my screen? Go solve question 3 now. I hope it is visible enough. So all of you should attempt question 3 and let me know what is the answer for you. You may use calculator, no issues for me. Similarly, okay, for solve this, then I'll discuss that. I want all of you to answer this because I've just solved a very similar question. Great. 2 people have answered already. Great. I should see more answers. So see, I'm not solving the current assignment. You people are only solving. I'm solving the related questions. So it will be very good if you can get it done within the class. At least we can verify what is the correct answer. Two more minutes. Okay, over. Super. I can see lots of answers. Happy to see. Let us see what is the answer. So he is also talking about commonness of S comma C2. The same formula L of WC upon LW comma CI, where I goes from 1 to n. That is L of W comma C2, L of W comma C1 links with W comma C2 plus links with W comma C3 plus links with W comma C4. That is quite straightforward, which is W comma C2. C2 is 273 over W comma C1 189 273 plus C1 plus C2 plus C3 plus C4 simply 87 and 53. This value is 273 by 602. 273 by 602. 602. The answer comes out as 0.45348. That is not an option. Is that 273 by, what have I done wrong? 189, 273, 87 and 53. But you are getting the answers, right? Where have I done wrong? Okay, I think.
Yeah, assignment data what we are using actually.
Okay, okay. Yeah, I think my options are not correct, right? 765. I think I copied from the previous one, maybe mistakenly. 765. Oh, just a second. Okay, let me see from the assignment and update here. Just a second. 765 389 453. 765 389 453. And what is the last option? No, what is the
0.910, correct.
0.910? Thank you. I think the only correct option was incorrect. Okay, clear? All of us are solving this way. Is this clear to all of you? This is your answer. ठीक है? Yes or no?
Yes, ma'am.
Great, super. Let us see if we have covered all the questions until 5. Yeah, we have, because we are randomly solving. Let me see if there is any other question on commonness. Yeah, I have solved it. Okay. This goes the solution for question 3, I guess. Great. Yeah, great. 4, 5, 6. Let me see if there is any other question on commonness. Yeah, this one. Any idea? So this is linking your two different topics, this week's lecture and the last week's lecture. These kind of questions maybe you can expect a little out of what you have seen, but yeah, can be a probable question. What do you think is the correct answer? And also let me know the reason why. Do not Google. It is requested not to Google. Any idea?
I think option B and C, anyone can have these two options.
Okay, and why is that? Why is that? Why B? Why
Uh,
C?
B, because it is talking about the prioritizing highly specific and informative terms.
Mm-hmm.
If we are talking about the commonness measure, so uh, commonness means that would be highly informative, means common to the documents that we are identifying.
Mm-hmm.
And option C, determine the chronological order of topic. These, if we are talking about the common, so if we have a topic, then we will link to the another topic.
I didn't understand your reasoning behind option C. Could you please elaborate?
Just like if we are talking about any one topic, like like any movement or history movement, so it will connect to the, it will link to the another topic, the further, that will be linked to that topic. So I think the chronological order of topic.
Would that
I'm not sure
necessarily
about.
be alphabetical? Even if it is linking, would that necessarily be alphabetical?
Not sure.
Okay. Any other what do others think about it? How many of you agree with option B? As of now, we have two answers. B. Okay. I'm not sure what the answer is, but I also think okay. So the answer goes like this. If you see why we introduce the concept of IDF, why we want to remove the stop words, those are highly common terms. They do not add any meaningful information. Okay, so this commonness measure, the more that particular word appears in a document, the more common it is. And in topic modeling, you want to identify the key terms, right? What the document is talking about, what that particular topic covers, all of that. So commonness helps you to filter out the stop words. Filter these out, that is stop words. From the name, it is clear that it will help you to filter out the stop words or the common words. Only then, yeah, the whatever is left would be the more informative things. And let me show you how I derived this. So see here. Is it not given here? So if you see in this article also, depth first search, it talks about depth first search, and here the commonness of a particular word is given. So tree as a word occurs many times, so it is very common throughout the document, so it is not adding much information to it. But if you see, uh, so you need to filter this out because this will not help you identify the topic quickly. Whereas if you see for tree as a data structure or tree as a graph theory, so the smaller value of commonness is recommended, because then it helps you to identify the topic more clearly, and it also indicates that this word does not appear quite commonly throughout your document. Is it okay? So little besides the mathematical formula, it's good if we can, you know, try to little look into it. Yeah, it's little out of the box, like how different topics can be linked and the questions can be given, but then this could help you to understand the two topics and link them together. So okay, moving back to where we were. So we covered okay, so yeah, question 6 quickly, can you tell? We have to cover these questions before the session ends. So could you please tell relevant features for a supervised model for predicting the topics to be linked? Is that relatedness, link probability, disambiguation, confidence? What is it? What are all the relevant features? That's why I say you should always know why every option is correct or incorrect. Because in exam you can have multiple choice or multiple select. This is also maybe a part of your assignment or quite related to it. So please attempt.
Ma'am,
Yes,
I have one doubt.
yes.
Uh, Key phraseness and commonness both are used to identify the topics. Can we say that?
Yeah, to some extent you can. So
Okay.
how
So
key phrase this helps you to identify? It helps you to identify the key terms, right? Higher the value, more it is linked to the topic. The more the document talks about a particular topic. But then what about commonness? It will help you to identify in a reverse way. Have you ever heard of reverse engineering?
yes, ma'am.
So similar way, commonness. It will not help you to identify the key terms, but it will help you to remove the unimportant term, the common term. That will eventually lead you to, identifying the key information, right? Or as
Yes,
we
ma'am.
said, the important topics, right? Understood?
Yes, ma'am. Yes, ma'am.
Okay, great. Now please
Thank you.
attempt this one. Yes. Thank you. Be little quick. We have lots to cover, or if it is needed, maybe I will cover later. What do you think is the answer? All of the above. D, option D. So both of you are saying option D. Any other answers? Is this a part of this assignment? Just a sec. So how many of you agree with option D? See, the answer is all of the above. Why? Because disambiguation confidence, it is like whether the particular entity like apple, it refers to the apple company or the fruit apple. So high disambiguation confidence score will tell you that the modern is certain that the particular word apple in the given document or in the given context refers to company or it being the fruit. So it reduces the risk of linking to the wrong concepts. Okay. And then relatedness is it measures the semantic similarity. As someone said while we were discussing a different concept, like a particular word can have particular different meanings, but it depends upon the context. Say the word rock appears. So the word rock could refer to the rock band, rock music, rock cafe, like it could be the name of some cafe, rock cafe, right? And yet another rock could be the conventional term in terms of stones and minerals, like so and so minerals are found in so and so rocks. So relatedness helps you to measure the semantic similarity. So whether the particular word rock refers to it being the name of some cafe or a band, or it being to some mountainous rock, depending on the surrounding score. So that's why it is said that the strong relatedness score suggests that the topic is contextually relevant. Contextually means what are the surrounding words for a particular word that we are talking about the query word. So it increases the likelihood of it being linked to the correct semantic meaning of it. Okay. And link probability could be like what is the strength of the connection, that is what is the probability that the particular topic should be linked with a given text. Some Wikipedia article is given, but then what does it talk about? Does it talk about sports, or does it talk about entertainment, or does it talk about education? So what if the particular topic is having a higher probability, then that article belongs to the that topic which is having the higher link probability. Okay. So it is a direct measure of linking the suitability. So here the correct answer is option D. I've also written it here. So I hope it's clear. This is just definition based thing. So moving ahead, what is the advantage of unsupervised relation extraction? This is from your assignment. Highly asked question. What is the advantage of unsupervised relation extraction? So I'm expecting all of you will answer. Just a minute. Please solve this, all of you, and I'll discuss in 2 minutes. So what is the correct answer? I can see lot of you are saying C. That is correct. Answer is option C, need no training data. So why? I've given here detailed analysis. So these techniques do not rely on manually labeled data, and it can so it is kind of a semi supervised technique. It can, we are talking about the unsupervised relation extraction, and the first definition here, can work efficiently with small amount of hand labeled data. This is the uh, criteria for semi supervised relations and not supervised. So this option is not correct, and it is not easily generalizable to different relations. There is no such concept, it can be generalizable. So this is no such concept. It needs no training data. This is fine, this is correct. And it always performs better than supervised techniques. This is not always the case, because both supervised and unsupervised techniques, they have their own pros and cons. So when we give a supervised means, the labels are already there. Say you are taking some data of emails and the labels are already given to you beforehand, ham and spam. So the model, using the given labels, it can clearly relate what kind of features refer, what kind of keywords or phrases appears in spam mails, and what does not appear in spam kind of mails. So sometimes it can learn better and it can perform better than the unsupervised methods, but that is not always the case. Okay, so the correct answer is option C. Okay. So it is not easily generalizable to different relations, because it can be disadvantage. This is actually a disadvantage. So highly specialized models, they struggle to adapt to new relation types. So moving ahead, can you tell which of the following is not a Hart's lexicosyntactic pattern for the automatic acquisition of hyponyms? So here, what first of all should be clear to you is these two terms. What is a hyponym? Then what is Hart's lexicosyntactic pattern? Similar question is there in your assignment. So I will not solve that, but I will solve this so that you can solve that. So all of you should attend. Analyze every option, because that will directly help you to solve your assignment question. Analyze every option. All of these are equally important. Because you never know in the exam, out of these options only you can get a new question. If you analyze each and every option, that means you are preparing that many questions for practice. Anybody able to answer, or shall I proceed with the discussion?